In the previous record, namely for the section 1.7, we defined the trigonometric ratio sine theta and cosine theta for the angle between 0 and 19 degree. We now remove that restriction on theta to define the sine function and the cosine function, each having the set of all real number as it is domain. Sine theta and cosine theta according to this right triangle. This is theta, A, B, C. Sine is B over C. Cosine is A over C. Okay. But here theta, because of the properties of the triangle, theta cannot be bigger than 90 degree. Actually here theta between 0 and 19 degree, or 0 and pi radian. Pi over 2 radian, sorry. We will use the letter x rather than theta to denote the independent variable, as we have done previously with the polynomial, rational function, exponential function, logarithmic function, etc. The definition is called unit circle definition of the sine and the cosine. Let x be the radian measure of an angle in standard position. What is the standard position? From the X-ray to the some point. Okay, I will explain. Angle in standard position. And let P A, B'nin Cartesian coordinate system be the point on the unit circle. So let's show that. This is unit circle. That means radius is 1. And the point P here, A, B, or equals AB. So on the unit circle, that lines on the terminal side of the angle. So which terminal side? This terminal side. What is initial side? Initial side is x-axis. So this is our angle theta. This is theta. But theta can be bigger than the pi over 2. So theta can be described by this way. Also, this is also theta. Sorry, x, not theta. We use the x of the angle. Then sine x equals b and cosine x equals a. Why? Let's try to show that on this triangle. X and this angle are the same angle actually. So this length is the B length. This length is the A length. So and the radius is 1, so r is 1, so the hypotenuse is 1. So sine x is b over 1, cosine x is a over 1, so which are b and a. This definition are known as a unit circle definition. We make the several important observations about this definition and its consequences. Okay, let's talk. The coordinates axis are the x and y. Maybe you say x angle, so let's change this coordinate axis. It can be they will be confused. So let's use another notation for the coordinate axis, u and v. U and v. Let's say coordinate axis are u and v. The coordinate axis in this figure, u and v axis, rather than the customary x and y axis, because x is used to denote the measure of the angle. So the sine of x is the second component or v component or v coordinates of the p, and the cosine of x the first or u coordinates of the p. Okay, this is the second component of p, this is the first component of p. Secondly, the definition applies to angle with positive, negative, or zero radian measure. Okay, here we have the some positive angle, but you can apply the negative angle. There is no problem. Let's denote. This color is okay. So this angle is the minus x angle. Okay. So this is minus x. So you can use this definition for all angle. That means the domain of the sine function and the cosine function in the set of all real numbers. Okay, so from this definition, we obtain domain of the sine x and the domain of the cosine x. Also, we will define tangent, cotangent, cosecant, etc. in the future. Are real is the real numbers set, the set of the real numbers. The point P lies on the unit circle, so its coordinates A and B are between -1 and 1, because this point is 1. This point is -1, so that means A is between -1 and 1. This point is -1, this point is 1, okay? So that means B is between this point and that point, so -1 and 1. So what that means, sine x between -1 and 1, cosine x between -1 and 1. So we obtained that fact. This is B1 properties, this is another property. So sine x between -1 and 1, cosine x between -1 and 1. Because P lies on the unit circle, a square plus b square equals 1. Okay, from this triangle by using the Pythagoras theorem, a square plus b square equals 1, and therefore sine x square plus cosine x square is 1, because sine x is b, cosine x is a. So third property is sine x square plus cosine x square is 1. And fifth one, the angle in the standard position with the radian measure x. The standard position means this part I showed the firstly. Okay, this is the x equals not x equals, sorry, x and the x plus 2 pi are coterminal. X and 2 pi are coterminal, or minus x is coterminal. No, minus x is not coterminal, because for the minus x, we go to counterclockwise direction. Clockwise direction. This is not the coterminal. Its initial ray is the green one, and terminal ray is the u-axis. So this is not coterminal, minus x, but this angle is minus x. So this red angle and the yellow angle are coterminal, okay? X and x plus 2 pi. Therefore, sine x equals sine x plus 2 pi, because these are coterminal, and cosine x equals cosine x plus 2 pi. That means the sine and the cosine function are periodic function with the period 2 pi. So let's write that fact. Sine x equals sine x plus 2 pi, and cosine x equals, this is for properties, equals cosine x plus 2 pi. So this means sine and cosine are periodic with the period. So that what does it mean? If you sketch the graph of the sine and cosine function on the interval 0 to 2 pi, it will be similar on the interval 2 pi, 4 pi, 4 pi, 6 pi, or 0 to minus pi, etc. The next property is the sine or cosine of angle measured in degree is equal to the sine or cosine of the angle measured in radian. So just the measure is different, but the results are the same. For example, sine 90 degree equals sine pi over 2, which is 1. Why? When the angle is pi over 2, you are here on the unit circle. So your point P is this point. What is the coordinates of the P? 0, 1. So here sine pi over 2 is 1. This is cosine pi over 2. And the next property is, if x between 0 and pi over 2, then the definition of the sine x and cosine x agree with the trigonometric ratio which is given in the section 1.7. Because P is on the unit circle, the hypotenuse of the triangle in this figure, let's show that. This is unit circle, P somewhere here. So we have this triangle. This triangle, this is A, this is B, and that is 1. So because of this triangle, because of this situation, the hypotenuse of the triangle is has the length 1. So this is 1. So the trigonometric ratio of the sine is B over 1, which is 1, and cosine is A over 1. So this is A. Let's write down. So for this angle x, cosine x equals A, sine x equals B.